Today we're continuing with the basic ideas of geometry. The next one we have on our Frere model is called a segment. A segment is a part of a line formed by 2 points, and those are called the endpoints, and all of the points between them. And you're like, well, there are no other dots in between them. Well, there don't have to be any dots. There are an infinite number of points in between A and B. We just haven't put dots on them or labeled them. When we have drawn this, we're saying there's all these other points in between here, but we just haven't named them. So this would be segment AB or segment BA. The order is not important. So our symbol or abbreviation, segment AB or segment BA, either way is fine. Some properties: segments are straight and finite, meaning they don't continue forever. Unlike a line is the parent. You start with a line and you take a little piece out, you take a segment out of it, it's the finite piece. It's also not the same as a ray, which is something that we'll also look at. All right, any questions about what a segment is? That's pretty straightforward. Let's go on to the next page. So I didn't want to do a whole Frere model for a ray also, but a ray is the part of a line formed by a point called the endpoint and all of the collinear points to one side of that point. Remember, what does it mean to be collinear? Volunteer? What does it mean to be collinear? Yes, ma'am.
2 points on the same line.
Yeah, and it could be more than two. But you're right, any 2 points will be collinear. But if you've got a group of points that are on the same line, they're collinear. So this is an example of a ray, and we'll call this ray RS. And this is the symbol. And the reason we write the R first and not the S first is that we're saying we're starting at R. So the end point, matches this letter, and then S is somewhere on here before it goes on infinitely in that one direction. So even though this ray points to the left, our symbol always points to the right because we read from left to right, at least in English. So that's why this is KJ. When naming rays, the endpoint always has to come first, no matter what. So, as I said a second ago, rays are straight and infinite, but only in one direction. Now, I mentioned yesterday that when you've graphed before, you've graphed on what's called the coordinate plane, which is on a piece of paper. And the primary characteristic of a plane is that it's flat. So in this room, things that are like a plane would be like the top of your desk. The top of your desk is like a plane because that's flat. Okay? What other things are like a plane in this room? Yes, ma'am? All right, piece of paper, right, unless it's been crumpled up, is like a plane. Think bigger. Somebody else.
The tiles.
Okay, the tiles on the floor, or even the whole floor itself, right? That's like a plane. So if the floor is like a plane, what else would be like a plane? The ceiling. The ceiling is like a plane. And although the walls in here are all broken up, if you take a piece of the wall, a section of it, like the one over there behind the bookshelf, that section of the wall is like a plane because it is flat. Now, unlike all of those things, a plane in geometry has no thickness. It is infinitely thin. And it extends infinitely in all directions. So the floor is not like a plane in that, because the floor certainly doesn't extend in all directions infinitely, and it does have thickness. Okay? So in geometry, what we do is we take what's called an idealized system, meaning the things that we look at have no imperfections. It's perfect. It's perfectly flat. It's completely thin. It goes on infinitely. Whereas real objects, there's nothing that's actually like that that's real. Any real object you have is going to have some thickness, and it's not going to go on infinitely, and it's probably not going to be perfectly flat. So here, we've got all these points on here. Notice that this is a capital cursive letter. It's not a point. It's a name for the plane. We can call this plane plane R. A plane can also be named by any three non-collinear, not all on the same line points that are on the plane. So we could call this plane ABC. We could also call it plane, how about BCD? Is that okay? Are those non-collinear points? That was a question for everybody. Are those non-collinear points? Yeah, those are non-collinear points. So if you name three non-collinear points, then you've got a plane. By the way, remember, the basic rule for this class is anything I write, you write. Okay, unless I tell you not to. And sometimes I will. I'll be like, don't worry about writing this. But if I write something, I expect you to be writing it as well. So we could call this plane BCD. And there's lots of other ones that we could do. All right, let's move on to page 3. Yesterday we talked about if two lines intersect. If two lines intersect, they can only cross at one point, right? Okay. It's also true that if a line is intersecting a plane, then the intersection is just a single point. Now, this is a drawing of a three-dimensional object. You've got plane P with lines XZ and WY both on the plane. Line AB is going through the plane. Try not to be distracted by the people outside. So line AB is going like this. It's going through the plane. And the question that people sometimes ask is, well, how do you know that that's what that's doing? Well, do you see how the line is solid until it gets to point X, and then it's dotted, and then becomes solid again? The dotted part is what's called a hidden line. You may learn about that in art or something. Okay, that's a hidden line. What's happening is this. From where you're sitting, can you see all of this red pen? There's part that you can't see, right? The part that you can't see is hidden from you by the plane. And so we draw that part as dotted to show it's still there. It's just that you can't see it. Okay? So in this diagram, line AB intersects plane P and line XZ at point X. Now, does AB intersect WY? Well, here's what this actually looks like. See if I can draw it correctly. If that there's WY, here's point X. My line AB goes through like this. Is it ever going to intersect WY? right? And that's kind of different. When you have thought about non-intersecting lines in your math classes in the past, they've always been parallel to each other. These two lines are not parallel. Okay, why don't they intersect? Because AB is not on the plane and WY is on the plane. And the point where AB goes through the plane isn't on WY. That's kind of a long explanation, but you need all of that. So line AB intersects plane P, but not at a point on WY. And maybe that's the shortest way to say it. The reason that these two don't intersect is that line AB intersects plane P, but not at a point on WY. And WY is on the plane. In this diagram, XZ and WY lie in plane P or on plane P, either way you want to say it is fine, and intersect each other at Q. Do you notice there is no dot at Q? We don't need one, because we know that if two lines intersect, you're going to get a point. So there does not need to be a dot there. Now, what about two planes intersecting? If two planes intersect, their intersection is a line. Now, before we talk about this some more, let's talk about intersection for just a second. All right, so if I could please, we're going to do a quick experiment. Everyone who has brown hair, please stand up. All right, thank you very much. You may sit down. Now, everyone who is taller than 5 feet 8 inches tall, please stand up. Everyone who's taller than 5 feet 8 inches, please stand up. All right, please have a seat. Now, anyone who has both brown hair and is taller than 5 feet 8 inches tall, please stand up. He is our intersection because he's part of both groups. He's part of the group that has brown hair and part of the group that is over 5 feet 8. Thank you very much, sir. Okay? So, a lot of times when people think of intersection in math, they're like, that means they cross each other. And that's sometimes true. But what it really means is they have something in common. They share one or more points. So when two lines intersect like that, how many points do they share? Just one. When two planes intersect, it's more than that. So let's look at this. This represents like a three-dimensional block of wood or something. Okay? Plane M is the top of the box. So plane M, let's go ahead and shade that in. Plane M is the top. It's all of this. Plane R, let me use a different color for that, is all of this. Where do we have points in common? Well, everything right here along this part of the box where the top and this side meet is it's part of both, right? Like point A, it's part of plane M and it's also part of plane R. Point B is part of plane M, it's part of the top, but it's also part of this side. And every other point in between those two is also on both of those planes. And even though the diagram doesn't show it, those planes keep going infinitely. So the intersection is going to keep going infinitely. This is going to keep going this way, and this is going to keep going this way. So the intersection of those two planes is plane AB, is line AB. Not just segment AB, not just A and not just B, it's all of these points. All right, are there any questions about that? Okay, then what we're going to do is you're going to go ahead and look on RenWeb or on my calendar, start on your homework, which is in your book, while I do a quick grade of a completion grade on your homework. If we have time, I'll pass them back and we'll go over answers. If not, we'll go over them on Monday. Okay, but your job is to look up what your homework is, either on RenWeb or on the calendar, and then use the book from Google Classroom and get started.